squares and square roots. So let's talk about square roots first. 7 raised to the power of 2. So this 7 is what we call base, and then this 2 is the power. So to pronounce this one, we say 7 raised to the power of 2. And the interpretation of this is you multiply this base by itself 2 times. Assuming that you have 3 here now, that means you need to multiply base by itself 3 times. So but for the sake of this one now, we have 2. So it's the same thing as 7 multiplied by 7 and is equal to 49. Now to now talk about square roots. So in words, the square of 7 is 49. And this is what is being written here. Exactly, square is equal to what? 49. Now we can turn this statement round and say the square root of 49 is 7. So if square of 7 is 49, it means that square root of 49 is 7. Now in symbols, so symbolically we have square root of 49 is equal to 7. Now the symbol is this symbol that I'm pointing at here now means the square root of. Is that clear? So anywhere you use this root, this sign, it means that you have to find the square root of anything that you have inside it. Now to find the square root of a number, first find its prime factors. Although prime factor is not the only method we have. For example now, so example 1, find the square root of 11,025. Now let's try to use these prime numbers first. The prime numbers, they are 2, 3, 5, 7 and so on. Now the workings now, so you need to continue dividing this number by the prime numbers now. So the first prime number is 2. Because of this 5 now, 2 cannot go here, 3 can go. So 3 in 11, 3. Is that clear? So 3 times 3, 9, that is remainder 2. So 3 in 20, that is 6, that is 18. 3 times 6 is 18, remainder 2. 3 in 22 is 7. So 3 times 7 is 21, that is to say remainder 1. Then 3 in 15 is 5. So 11,025 divided by 3 will give you 3,675. So what can go here again? 3 can go. So 3 in 3, 1. 6 divided by this 3, 2. 7 divided by 3, 2. Remainder 1. That 1 and 5 will be 15. 15 divided by this 3 is 5. So here now, 3 cannot go here again. Exactly. So 3 cannot go here. So 5 can go. You say 12 divided by 5, 2. Remainder 2. Now that 2 plus this 2, that is 22. 22 divided by 5 is 4. 4 times 5 is 20. That is remainder 2. Then in 25, 25 divided by this 5 is equal to 5. So 5 can go again. So 24 divided by 5 is 4. Remainder 4. Then that's 4 and 5. That is 45. 45 divided by this 5 is equal to 9. So 5 cannot go in 49. So the next prime number is 7. So 49 divided by 7 is equal to 7. So this 7 divided by this 7 will give you this 1. So is that clear now? So meaning that 11,025 now, the same thing as 3 multiplied by 3, multiplied by 5, multiplied by 5, multiplied by 7, multiplied by 7. Is that clear? Now, so let's now look here now. So we have 3 in 2 places. So that is 3 raised to the power of 2. Then we have 5 twice. So 5 raised to the power of 2. We have 7 twice. So we have 7 raised to the power of 2. Now, since this one, they are in twos now, so you can just pick 1, 3, 1, 5, 1, 7 in one bracket, second one in another bracket. So 3 times 5 is 15. Then 15 multiplied by 7 will give you 105, which is 105 multiplied by 105. Exactly. Therefore, the square root of 11,025 is equal to what? 105, because it's like we are multiplying 105 multiplied by 105. Then we get this 5. Exactly. Now, another method now, if you don't want to go through you can just find two numbers that you can just use to multiply just a number multiplied by itself that will give you what's inside this sign. Now let's do example 2 to look at that. Now example 2, find square root of 6,400. 6,000 what? 400. Now let's see how this one will go now. The solution. So you know 6,400 is the same thing as 64 multiplied by 100. Now 64 is the same thing as 8 multiplied by 8. Then 100 is the same thing as 10 times 10, which is 10 raised to the power of 2. Now since you have 8 twice, now pick one. You have 10 twice also, just pick one. So 8 multiplied by 10 is equal to what? 80. Therefore, the square root of 6,400 is equal to 80. Exactly. So square root of 6,400 is equal to 80. And if you like, you may follow the prime numbers procedure. That is, you continue the 6,400 by prime numbers till you get 1. Exactly. So this is another method. So under this square root. Now let's look at squares now. We have talked about square roots. Let's talk about square now. Now let me firstly introduce the concept of perfect square. So for example, now if you have 9, now 9 is the same thing as 3 multiplied by 3, and we say that the square root of 9 is equal to 3. I think I've explained this one on the first and the right. Then 25 is equal to 5 multiplied by 5. Therefore, square root of 25 is equal to 5. That is what we have here. So the same thing for 225 is the same thing as 15 multiplied by 15. Therefore, square root of this is equal to 15. Square root of 9,216 is equal to 96 multiplied by 96. Therefore, is equal to 96. So we say that this 9, 25, 225, 9,216, they are perfect squares because their square roots are all numbers. Exactly. Now, a perfect square, this should not be the definition of a perfect square now. A perfect square is a whole number whose square root is also a whole number. Is that okay? You can find the square root of a whole number. For example, now this is a whole number. Now if you find the square root of this 9, now the answer is 3. So 3 is also a whole number. Is that clear? Now let's now see. So it is always possible to express a perfect square in factors with even indices. For example, now this first example, now if you look at the power of 3 is 2, power of 5 is 2, power of 7 is also 2. So what we are saying here is that we are not saying that all the powers now must be 2, but must be even. Notice this one must be what? Even. So 2 is even, 2 is even, 2 is even. And 2 is not the only even number that we have. Is that okay? So we have other even numbers like 4, 6, 8. It is possible to have something like that. Now let's look at example 1 here. They say that find the smallest number that 540 must be multiplied by so that the product is a perfect square. So meaning that if you find the square root of this 540 now, you will not get whole number. So how will you now find the smallest number that must be multiplied by this 540 to get a perfect square? So the simplest way to do that is use these prime numbers now. Start from 2. Continue dividing 540 by 2. Now at the end, so any of the answers now that any of the answer that is not having even power, then we make the power to be even. Then so we now try to multiply. So this is what we are saying. Let's see. Now, so 2 can go in 540. 5 divided by 2 is 2. Remainder 1. That 1 and 4 making 14. 14 divided by 2 is 7. Then 0 divided by 2 is 0. 2 can go again. Then 2 divided by 2, 1. 7 divided by this 2, 3. Remainder 1. That 1 and this is 0, making 10. So 10 divided by 2 is 5. So 2 cannot go here again. So 3 can go. 13 divided by 3, 4. That is remainder 1. Then that 1 and 5, 15. 15 divided by 3 is 5. So 3 can go again. 4 divided by 3, 1. Remainder 1. Then 5, making 15. 15 divided by 3 is equal to 5. Is that clear? Then 3 can go in 15. So write 3 here. So 15 divided by 3 is 5. So 3 cannot go in this 5 again. So you now come and write 5 here. So this 5 divided by this 5 is equal to 1. Now you can see that you have 2 twice. 1, 2. Then you have 3. 1, 2, 3. 3 times. So 3 times now, you know that 3 is odd. It's not even number. Then 5, we have just 5 once. Now let's try to write this the primes like this format now. So 540 is the same thing as 2 raised to the power of 2. That is 1, 2. Then 3 raised to the power of 1, 2, 3. 3 times. Then 5 once. Now the index of 2 is even, which is 2. So the indices of 3 and 5, they are odd. So the index of 3 is 3. That of 5 is 1. Is that okay? Now to now make this one to be perfect, so we now, if you had 1 3 here, then 1 5 here now, so the 3 and 5 that are not part of this before, that will now make the power of this one to be even and the power of this one to also be even now, is what we will now write out, which is 3 multiplied by 5, which is equal to 15. Now if you now multiply this 15 by 540, so the answer, the product, will be a perfect square. Is that clear now? So what we are saying is that one more 3 and one more 5 will make all the indices even. So the products will then be a perfect square. So the power of 5 here is 1. If you had another one now, it will be 2. So the power of 3 is 3. If you had 1 now, it will be 4. 4 is even, 2 will be even here. So the 3 that you are adding here is what I wrote here. The 5 that you are adding here now, so 3 multiplied by 5 is equal to 15. Is equal to what? 15. Now if you multiply this 15 by 540, so the product, the answer that you will get will be a perfect square. It will be what? Perfect square. So now if this one is clear now, I would like you to practice the following exercises for me. So find the square root of the following: 196, 441, then 4900. Use any method of your choice. Smallest number by which this must be multiplied so that their products are perfect square. So like this here, 2 times 2 times 2. So you know that you have 2 3 times now. You had another 2. So 3 now is already even. Then 5 is odd. So add another 5. So 2 times 5, that is It's like I'm telling you the answers. So here now, 2 raised to the power of 3. You need to add another 2. So this one is even. So this one is odd. So 1, 11, then 1, 2. So 2 times 11 is your answer. Then 2 raised to the power 6. 6 is even. 4 is even. So this 3 is odd. This 3 is odd. That means you need 1, 5, and 1, 7. So 5 times 7 is your answer here.